Hello and welcome back. This is Joseph Kai channel. Today we are going to talk about how the binary search function is working. The binary search function takes an array of integers and a key as an argument and returns the index of the key in the array if it exists. Otherwise, it will return -1. The binary search function is an implementation of the binary search algorithm, which is used to search for a specific element in a sorted array. So we can only do a binary search in a sorted array. The function takes two arguments, the nums array, which represents the sorted array, and the key, which represents the elements to search for. This is how we implemented the binary search functions in C#. We have the sorted array, which has a 7-digit number from 1 to 7. In computing memory, remember that an array index starts counting from 0. The functions initialize two variables, L and R, which represents the left and the right boundaries of the search range respectively. The initial values of L is 0, and the initial values of R is the length of the nums array, -1. In this case, why do we have -1? Let us have a look at. We have 7 digits in our sorted arrays. However, we only have 6 indexes because the computing memory index starts counting from 0. So if we want to get the total number of indexes, we need to subtract 1 from the length of the nums arrays. So we have 6 total indexes. Otherwise, it will get an index out of bounds error. We have a binary search functions algorithm in C#. The functions then enter a loop that continues until the search range is empty or the key is found. In this code, we have a while loop. While loop means until we satisfy these conditions, L is less than or equals to R, this block of code will be running. In each iteration of the loop, the functions calculate the middle index of the search range using the formula L plus R divided by 2. In this case, we are adding the leftmost index and the rightmost index and dividing by 2. So we get the middle index. In the next statement, if the search key is equal to the element at the middle index, the function returns the middle index. In the next statement, if the search key is less than the element, the function updates the values of the right to be middle -1, which reduces the search range to the left half of the array. In this case, the middle index is 3, which is number 4 in our sorted array. So the R becomes the second index, which is number 3 in our sorted array. In the next statement, if the search key is greater than the element at the middle index, the functions update the values of L to be middle +1, which reduces the search range to the right half of the array. In this case, the middle index is 3. When we added 1 to the middle index, L becomes 4th index, which is number 5 in our sorted array. In the last statement, if the search key is not found in the array, the function returns -1. Now we are going to have a look at how the search functions actually work in real life. Assuming that we are going to search element 3 using binary search algorithm in the sorted array. Here we initialize two variables, L and R. We set L to be 0 index and R to be 6 index. We have to subtract number 1 from the nums arrays of the length. The num arrays of the length is actually 7. Inside the while loop, the middle index becomes index 3, which is number 4 in our sorted array. And then in line number 22, we check if the search key is equal to the middle element. In this case, our middle index is 3, which is number 4 in the element. So it is not equal to our search key. So we skip this block of code and jump to the next conditions and check if the search key is less than the middle index. In this case, the search key is less than the middle element. The middle element is in the 3rd index, which is number 4 in our sorted array. So we update R to middle -1. So R becomes index 2, which is number 3 in our sorted array. Now the while loop is checked and L is less than or equals to the right. Yes, L is 0 and R is 2, so L is less than R. So we are running this block of code again. In this case, the middle index becomes 1, which is number 2 in our sorted array. We again check if the search key is equal to the middle element. In this case, the middle element is 2, which is not equal to our search key. Our search key is 3. So we jump to the next statement and check if the search key is less than the middle element. In this case, the search key is not less than the middle element. So we check that the search key is greater than the middle element. In this case, the search key is greater than the middle element. So L is updated to middle plus 1. So L becomes second index. We already updated R to second index as well because the search key is less than the middle elements in the previous statement. Again, we are checking the while loop conditions. L is less than or equals to R. In this case, L is the second index and R is the second index. This condition is still satisfied because L and R are equal. So we are still running this block of code. So the middle index becomes 2. In the next statement, we again check if the search key is equal to the middle element. In this case, the search key is equal to the middle element, so we have found the search key in the second index. Now, we exit the functions and print out the second index on the console. This is how binary search algorithm is working. Thank you very much for watching. Please subscribe to in the future. Bye.